Hey guys, this is Dr. Z. In this video, we're going to talk about the effect of trade on the factors price change. We know in the Hector-Rayleigh model, when two countries engage in international trade, the wage of the workers and the rental rate of capital are going to change. So that determines which group will oppose the international trade and which group will support it. And we summarize that as the Stolper-Samuelson theory. So we're going to use one example to prove that which factor gains, which factor loses from trade, and to distinguish the winner and loser of the international trade here. So pull out a piece of paper and prepare your pen, and we're going to work on the question together. Let's get started. So in this video, we want to talk about the Stolper-Samuelson theory, which actually tells who is going to be the winner, who is going to be the loser in trade. So in the Hector-Rayleigh model we discussed before, it has something indifferent from the traditional Ricardian model and neoclassical model because in the Hector-Rayleigh model, the winners and losers will be identified in the trade. So that explains why in most of the time there will always be some group in the one country their benefits will be harmed by this international trade, so they're gonna oppose the international trade, free trade. So this Hector-Rayleigh model we'll use to explain that. So the Hector-Rayleigh model was named after two U.S. economists, the Wolfgang Stolper and Paul Samuelson. They introduced the Stolper-Samuelson theory. And in this theory can be summarized as trade commences, the owners of relatively abundant factor will find their real income rising, and the owners of relative scarce factor will find their real income falling. So here we talk about the real income, which is the nominal income divided by the price level. The price will be the price in the Hector-Rayleigh model, which is the price of good X and good Y. So we're gonna check both of these conclusions by using one example. But in general, the idea is very easy to understand. So say if US trade with China and they trade on two different goods, one is labor intensive, one is the capital intensive. So for United States, if US export most capital intensive goods to China, then according to the Stolper-Samuelson theory, which means the capital is the bottom factor in US, then when the trade commences, US will find the real income to the capital, or real rental to the capital, will rise. Well, the real income to labor, which is the scarce the scarce factors for US in that case, will find the real income falling. The nominal income may still increase, but real income will fall. So that's something we'll use to explain a lot of things that dealing with the trade, someone opposing the free trade, because the trade itself will generate losers at this point. Okay, so let's talk about the Hector-Rayleigh model theory and distribution of income. According to the Stolper-Samuelson theory, if US is relatively capital abundant, who in the Americans should favor the free trade. So think about, we just talked about the case, and you should have some idea, but we will go back to this conclusions later. All right, and who is favoring protectionism? Okay, so the question we're going to use to prove the real return of the income under the Hector-Rayleigh model, we're going to use one specific question. We assume that there is home country and the foreign country, and here we only care about the factor price change, which is wages and real rental rates of the capital change for the home country. So we may actually derive a separate example for the foreign country, but here we only focus on the home country. So home country is gonna produce two different goods, computers and shoes. So basically you can imagine this computer will use both labor and capital, shoes will use labor and capital, and we do have the information of the sales revenue, earning of labor, which is to produce computers, you need to hire workers, and this earning of labor is the payment to labor. And earning of capital is to produce something, you need to use the machines, equipment, and earning of capital is the payment to the capital. All right, so that applies to both computer and shoes, and also we assume that with the trade commences, we do have the computer price and the shoes price will be changed. Computer price will increase by 10% and shoes price will remain unchanged after the trade. So based on this information, actually, this is a typical Hector-Rowlin like model, and we can try to derive some equations, and finally we can calculate the return to the workers, which is as a wage rate change, and the return to the capital as the rental change, and we'll compare the nominal term and the real term together by using this numerical like a test. All right, so this question is going to be posted on the page. This is also a sample question, so you can download the questions along with this video. And I suggest you also use a piece of paper and prepare the pen to write it down and follow the video with me step by step, because in our next test, this type of question, most likely will be tested again as kind of challenge point that I will remind you. Okay, let's start it. Okay, so this sample question has been posted on the same page, and I put it out, and you can see this in the PDF. They provide exactly the same information. Two industry will be the computer and shoes, and we have the sales revenue and payment to labor, payment to capital, and also we have percentage change in the price of computer increased by 10% with trade, and sale for shoes, payment to labor for shoes, payment to capital for shoes, and percent change in the price of shoes will be remain unchanged. So those are given questions, given conditions. Let's take a look at the questions. The first question is to talk about which industry is capital intensive, and also question, is this a realistic scenario? And the second one is given the percentage change in the output prices above, calculate the percentage change in the rental on capital and percentage change in the wage of labor, and how does the magnitude change in the rental to capital and compared to with that of labor. That's the second one. And the third one is which factor gains in the real term, which factor loses. Are these factors consistent with the Stolper Samuelson theory? Those are three questions. Okay, so as you can see here, I have already put down the computers industry. The sales revenue equals PC, which is computer's price, times the quantity of computer being sold, equals $100. And the payment to labor, which is if you need to hire some workers to produce computers, that is workers' wage rate W for this country times how many labor used in the computer industry, which is LC represent labors in computer industry. That number is 50. And the payment to capital is all the capital stocks used in computer industry, KC, times R represent the rental on the capital, equals 50. So we don't need to know exactly the total value of PC, QC, WLC, or KCR as individual values there, but as long as we can find that the total value here, then that would be fine. That would be fine. Once we got the computers industry, we can start working on the shoes industry. Okay. Now we got this shoes industry. The sales revenue is the price of shoes times the quantity of shoes equals 100. And the payment to labor, which is you hire workers working for the shoes industry, the workers' total amount of LS, labor supply in shoes industry, times the wage rate, that's $60. And for the capital, we got the KS, which is the capital used in shoes industry, times the rental on capital equals $40. Equals $40. And you may notice this numbers are not random. So if you adding this 50 plus 50, you got 100. If you're adding 60 plus 40, you got 100. So this is not a coincidence. The explanation is, remember, we made the assumption under the Heckscher-Rowling model that is, when we have that the country produce those things, then we have this perfect competition, perfect competitive market in the production. So in particular case, we will find that in the perfect competitive market, there is a zero economic profit, which means if we actually have $100 as the total revenue for producing computers, and that revenue will equals the cost of production, the cost coming from hire workers or renting the capital. So that equals the money spent producing it. So there is no economic profit. This total revenue equals total cost, so profit will be zero. And so does for the shoes industry. Total revenue, $100 equals total cost of labor plus cost of capital, 60 plus 40, which is also as a total cost. Okay, now we have this basic condition set up. Then the question is, between computer and shoes, which industry is capital intensive, which industry is labor intensive? So in our mind, we presumably thinking that computer should use more capital, should use more labor, but we need proof. So for any type of question, you cannot just say, I think, but you need to prove. How to prove that? Remember, we said if one industry has the like a capital intensive intensity, then that industry must has a higher capital to labor ratio. So we can use that. So for computer, we can use the payment to labor and payment to capital here. So for computer, we can use payment to capital divided by payment to labor. So for computer, we have KC times R divided by W times LC. That equals how much? We know KC divided by bar times R equals 50. And W times LC equals 50. So 50 over 50, that's easy, equals 1. And if we only care about KC and LC, then we can see this KC over LC equals how much? We actually will times W on both sides of this equation and then divide by R. So we got this 1 times, we times W on both sides, divide by R on both sides. So KC divided by LC equals W over R for computer. And for shoes, then we use the payment to capital for shoes and payment to labor for shoes. That's going to be KS times R divided by W times LS. So that equals KS times R equals 40 and W times LS equals 60. So the number is going to be 2/3. 2/3. That's 40 divided by 60 is 2/3. So once again, we care about KS over LS. Then we times W on both sides. So we use 2/3 times W divided by R on both sides, divided by R. So the second KS over LS equals 2/3 times W over R. So as long as this W over R is positive, so you can assume W equals R, so W over R equals 1. So KC over LC equals 1. And KS over LS equals 2/3 times 1. So it's only 2/3. As long as W over R, the price of workers' wage rate and also the rental to the capital are positive. So we will always have KC over LC is going to be bigger than KS over LS. So capital labor ratio used in computer here will be bigger than capital labor ratio used in, well, the shoes industry. So that means the computer, in our case, is capital intensive relatively more than the shoes, and make shoes are labor intensive. So this actually confirmed what we expected in this case. Computer is capital intensive, shoes is labor intensive. So the country, depending on the country's factor abundancy, the country can actually export its abundant factors intensive goods. So this is something, as for the first part of question, we can prove that computer is capital intensive. Okay, so for the second question, it's about to tell the change in the workers' wage rate. So we are looking for a term of the change in workers' wage rate, and this is the absolute change. So sometimes it's not easy to find absolute change. Then we find delta W divided by W as percentage change, and delta means change. Delta means the change. We use change in workers' wage rate divided by workers' wage rate before, we got percentage change, and that will show how the factor price change. So if workers increase a wage change from $100 to $110, workers' wage change by 10%. So we are looking for the other one is the change in rental to capital divided by rental to capital. So this is for labor, this is for capital. So we are looking for the factor price, which is workers' wage rate and the rental on capital, and to see with the trade the labor and versus capital, who is the winner, who is the losers in this particular case. Okay, so before we jump into the calculation, all the equations, we need to actually take a look at the questions itself and think about all these conditions that we have, and think about the particular the possible conclusion we can draw. All right, so the other thing that you should understand that it's given is the change in the price of computer. Delta PC over PC increased by 10%, and the delta PS over PS, the price of shoes, did not change. So this is also very important, useful piece of information. So if computer price keep increasing and the shoes price doesn't change, if I ask you the relative price of computer, which is computer price divided by shoes price after trade, what will happen to this relative price? If computer price continue to increase but shoes price will be constant. If that is the case, then how will be this relative price PC over PS change? I think you got it. So the entire relative price ratio is going to increase if price of computer increases and the shoes price is constant, doesn't change at all. So the entire price will also increases. So what's the meaning of this relative price change? So think about again. So when we talk about the relative price change when the country engage join the trade, under what situation the country's relative price increases? You still remember that when we talk about when country exports something to the other country, then the international price will increase, will be bigger than its autarky price, because that's the incentive why this country is gonna export this good in the first place. So as relative price of computer increases with the trade, and I can say that country will export computer. The country will export computer because the relative price of computer increases after trade. The country must export the computer. Now think about the Hector-Rollin theory. Okay, so if the country export computer and computer is capital intensive, that is from the first question that we compare between computer and shoes industry, compare the KL ratio, and we find the KL ratio in computer is bigger than that KL ratio in shoes. So computer is capital intensive, and this country exporting this capital intensive goods, and then this country must have abundancy in the capital according to the Hector-Rollin model to be able to export the capital intensive goods, right? So we actually derive this backward. If the country export computer and the computer is capital intensive from the first part of the question, then we got that this must be true that the country must be abundant in capital and scarce in labor. Labor is scarce resource. And abundant, the country must be capital abundant. Okay. Now, if country is capital abundant and labor scarce factor, we already talked about the Stolper-Samuelson theory, and we want to prove it here, but we haven't proved it yet. But think about Stolper-Samuelson theory. It tells us who's going to be the winner, who's going to be the loser. And the abundant factor will be the winner, according to the Stolper-Samuelson theory. And the scarce factor is going to be the loser. This is the loser. So the winner is capital, the loser is labor. Under this situation, in this question. So in this case, what the winner will be? The capital will be the winner. So that means the rental on capital should increase. So after trade, the capital can earn more income. That's the definition of winner. A loser, the labor, is going to lose. The loser's definition is after the trade, the wage rate is going to decreases. So you suffer a loss in income. That is the definition of loser. So this is what we expecting, the wage rate we expect when we calculate the change in wage rate. And we expect the wage rate is going to decreases. And when we calculate the change in rentals of capital, we expect the rental should increases. Should we do this calculation and find out that our expectation is correct, then that means, well, this Stolper-Samuelson theory does work. Otherwise, congratulations, you find the big mistakes in the modern international trade, and you still find something very interesting, right? But let's take a look at this and to see how exactly we find the change in wage rate and the change in rental. So bear with me. So the next steps, the derivation process will be really long, so you should be patient. And the best way to learn this is actually to pull out a piece of paper and start writing down the equations with me. So that will be the most effective way to learn this part. Okay, so let's get started from computer industry. And first of all, we should write down for computer industry, the conditions under this perfect computation, which is we understand the price of computer times quantity of computer, which is the total revenue computer equals what? Total revenue used to pay for all the factor of production in the cost. W times LC plus KC times R. Okay, so 100 equals 50 plus 50. That is computer industry. Okay, from this equation, remember, we try to find actually both delta R, rental change as percentage, and also delta W or W. Those two are something we try to find. So first of all, we should single out this R. How should we do? From these equations, we can put the W times LC to the left-hand side by subtracting both sides by W times LC. And we have this KC times R on one side. So we got this KC times R equals the payment to the capital equals for computers total revenue minus the workers wage rate paid to the workers in the computer industry. So we got this equation hold. So basically we actually put the KC times R on one side and put the total revenue minus payment to the labor on the other side. Okay, so right now we try to single out this R. So R equals, we actually copy everything on the right hand side, PC times QC minus W times LC, and divided by the KC. Okay, now actually we got equation for the rental to capital in this case. So from here, there will be some tricky part. I want you to pay close attention to see how I transform from one step to the other and how do this transformation. But once I did this transformation, all you need to do is to understand that and maybe remember it because our exam is going to be open book. So once you know that, you just remember these final equations that you can use. But here I will show you how to derive that for one time. So here, this is the total level of rental on capital. We try to figure out the change. Delta R means the change in R. So what can change the rental on capital in the hexagon model after the trade? Both could be change will be the wage rates, and also will be the rental change will be the price of the goods change. So in this case, the nominal terms change can cause this rental change. So let's see, this change in rental actually can come from the change in price of computer. So equals the change in price computer delta PC times computer's quantity minus could be change of the wage rate delta W times LC divided by KC. So in this time, we actually find out the change of the rental to capital coming from the other price change, the price of the workers and also the price of computer, and holding the quantity unchanged. So this is the first tricky part. So you should try to understand this. And the second part is actually, if you take a look at this thing that we are looking for, we are not looking for delta R only, the absolute change in rental. We're looking for delta R over R, which is a percentage change. So what do we do here? We have delta R here, and we want to divide by R on left hand side, and then we have to divide by this R on right hand side. So we divide by R on both sides, this equation still hold. And now we got what do we want, which is delta R over R, and equal a bunch of the equation on the right hand side. Okay, if you understand this part, then the next part is gonna be not easy, but will be a little bit more tricky. Okay, let's take a look at that. I'm just scare you. So it won't be that tricky. So we copy the left hand side because this is something we want to track. So we want to see the right hand side. We don't know what is the change in PC times the quantity of C because we only know delta PC over PC. We don't know delta PC itself. So what should we do with this part? So here's another tricky part. So in this part, delta PC times QC, we actually use a special way to do it. So we expanding this term. So delta PC, we actually divide by PC. Delta PC, we divide by PC. And then we times this PC back. And then times this QC. So if you check those terms, delta PC times QC, that equals delta PC divided by PC times QC. Those PC can be cancelled, and we still got delta PC times QC. So they are the same. So why should we do this? Make something like seemingly more complex. So we expanding a two terms like a calculation into four parts. Why should we do that? If you check closer, you will find we do know the delta PC over PC this value, which is given in the question, and also the PC times QC. This is also given. The PC times QC is the total revenue of computer. So by expanding from 2 to 4 terms, we actually can substitute the values that given in the question into this part and solve both of them. So that's something I think is really convenient. Now let's take a look at the second part, minus delta W times LC. So once again, we don't know what it is, but we can transform delta W and we divide by a W, and then we times this W back. and then times LC. So this W or W should equals 1. So the term equals delta W times LC. So they are the same. And once again, the two term delta W over W is something we are looking for. And the W times LC is something is given in the question because this total revenue is 100, W times LC is 100, KC times R is 50. So we got this part, also the values we can use. And finally, in the denominator is KC times R. You know what? That's the value is given. All right. So everything is good. So if you in the exam, hopefully you don't need to do this every time all over again. So in the exam, everything you need to remember is this part, this equation. So I just highlighted. So in the exam, if you understand this equation, you will be good. You will be good. You don't need to worry about the others. So if you understand this equation, you will be good. All right. So from this equation, what we do here is we know delta R over R is something we try to solve, and in this ratio, this fraction number, in the numerator, del PC over PC is percent change in price of computer, which is given as 10% increase in computer price, and PC times QC, which is 100. And the minus delta W over W is something that we're looking for. And times W times LC, which is payment to labor in computer, is given 50. Divided by KC times R, which is also given in the question, equals 50. All right, so we are getting down there. So you see that this 50 divided by 50 will be canceled. And this 100 divided by 50, that is 2. 2 times 10% is 20%. So a simplified the equation will be delta R over R equals 20% minus delta W over W. Okay. So actually, we can call this is the equation number 1. This is the equation number 1. Okay, so we are trying to solve both the percentage change in rental and the percentage change in the wage rate, but it turns out currently we only have one equation but two unknown variables. We cannot solve like two unknown variables with one equation. That's impossible. So we got to have the second equation and to make it a two equation, two unknown variables situation, so we can solve both. So the other equation, as you can imagine, this first equation from computer industry. The other equation is gonna from the shoes industry. Okay, so it's gonna be a long video. So for shoes industry, let's do this again. So price of shoes times quantity of shoes, that's total revenue of shoes, equals the payment to labor working in the shoes industry, W times LS, plus the payment to the capital, which is capital used in shoes industry, KS times the rental in the shoes industry. Okay, so you may notice that we know that the total revenue for shoes is 100, and also total payment to labor is 60. So shoes industry is labor intensive industry, so the payment to labor is going to be higher, and payment to capital is lower, 40. And also you can see here this W and R, like the wage workers wage rate in shoes industry and rental to capital in shoes industry, will be exactly the same as the wage and rental for labor and capital in the computer industry. Why this is the case? Why the workers can working for the computer industry or shoes industry and still earn the same income? Because one of the assumptions we assume in the Hatch-Run model is the factors, the laborers and the capital can move freely between two industries. If the labor, say the worker find in one industry can offer them higher income, they're gonna move to that industry, and this will change labor supply and demand in both industry and equalize the wage rates eventually, and so does the capital rental eventually. So that's why we will have the same wage rate and the rental rate on both industry. And still remember that our goal is to find the delta R over R and the delta W over W to find the second equation that include both unknown variables. And how to do that? Once again, from the first equation, we put Ks times R to one side. So payment to capital equals the total revenue, PS times QS minus the payment to labor, W times LS. So that is the, put the payment to capital on one side. And then what we do here is we can use the single out R equals PS times QS minus W times LS divided by KS. That's the second step. And the third step, if you remember, we will find the change in rental, and that change in rental comes from the other two price change, either the change in price of shoes times QS minus the change in the wage rate times LS divided by KS. All right. And then the next step is we will divide by both sides by R to make the left-hand side what we need, the change in percentage change in rental. Okay, and then remember the last time we said this is the very tricky part, which is we expand this delta PS times QS to delta PS divided by PS and then times the PS back and times QS. And because this delta PS over PS and the PS times QS are all given information, minus delta W, we divide by W times the W back times LS. So in this case, we expand the delta W times LS to these four terms because delta W over W is something we are looking for, and W times LS is the given information, 60, and the denominator is KS times R, which is 40 right here. It's given. So in this case, we got WR divided by R equals the denominator part, the change, percentage change in price of shoes. You know what? That equals 0. And it does not matter how much is PS or QS, PS times QS, because 0 times anything is 0. Minus, we are looking for delta W over W times W times LS, which is 60 in this case. And then divide by KS times R, which is 40. Wow, we are really getting there. So in this case, the first part, nothing there. The second part is 60 divided by 40, which is 3 over 2, and with negative sign. So that shows the second equation, which is the rental percent change in rental equals negative 3/2 of delta W over W, which is the percentage change in the wage rate. And we call this equation number 2. Okay, so if you still remember the first and second equation, and with 2 equations and 2 unknown variables, we can definitely solve it. So how to solve it? Let's move on to the next page. All right, so we got those 2 equations. Actually, I copied those 2 equations from the first 2 pages, equation number 1, equation number 2. So we have 2 equations, 2 unknown variables. Supposedly we can solve it. And this is about the algebra. If you guys, didn't do this for a while, it becomes a little rusty how to solve it. And here is something that we can do together. So we assume, to make things a little bit simple, delta R over R, the rental to capital, equals X, that's the variable X. And then delta W over W equals Y, X and Y. So from the first equation, they will substitute the X and Y into it, so X equals 20% minus Y. From second equation, we got this X equals negative it's not 2/3, it's 3/2. Otherwise, it's going to be a very weird result. The 3/2, I find out the mistake. 3/2 delta W over W. Oh, sorry. So it equals negative 3/2 Y. So we already changed everything. 3/2 Y. Sorry about that. Now we have x equals 20% minus y from the first equation. Second equation, x equals negative 3/2 y. Okay. All right. So how to do this? So we call this the third. This is the fourth one. So because left hand side they are equal, so we can actually substitute 3 into 4. So 3 equals x equals 20% minus y. This is into the 4, which is the left hand side, equals negative 3/2 times y. Okay. All right. So in this case, we can do is we can add y on both sides. So left hand side this negative y and y will be cancelled, and right hand side is negative 3/2 y, which is negative 1.5 y plus y. So negative 1.5 plus 1 is negative 0.5 y equals 20%. Equals 20%. And then we divide by negative 0.5 on both sides, which is negative 1/2. So right hand side we have this y because they are cancelled, and left hand side we got this 20% divided by 0.5 with negative sign, so this is going to be negative 40%. Okay, now we got this y equals negative 40%. We already saw the y from here, negative 40%. Sorry about that. And how about x? So we can call this 5, number 5. We can substitute 5 back into either 3 or 4. So let's do 3 into 3. So 3 will be x will be 20% minus y, which is negative 40%. Remember, you should include the negative 40% negative sign there. Otherwise, it will be different. So 20% minus y, y is negative 40%. And this negative minus this negative sign will becomes the plus. So this is going to be 20% plus 40%. So we finally got what we want here is x equals 60%. 60%, which is 6, number 6. Finally, we solve both x and y. And what about x and y? We assume x is the percentage change in rental, and y is percentage change in wage rate. So basically, finally, we got this delta R over R equals 60%. Okay, and finally, delta W over W equals negative 40%. All right. Okay, finally, it takes us over 40 minutes to derive this, but we got what we want. You know what? We got this results. It's very nice, beautiful results. So apparently, the rental on capital will increase and wage rate will decrease by 40%. So capital will be the winner. Labor, unfortunately, in this game loses. So if we go back to the, well, maybe 10 page before, let's see what's happening. This is the first page that we write down this model, and we assume that according to the Stolper Samuelson's theory, the change in workers' wage rate is going to go down. And we do find it will go down to 40%. And the change in the rental rate will go up. And we do find it increased by 60%. So actually, we got exactly what we predicted, even before we start everything. So wage rate decreased by 40%. The rental increased by 60%. And it do conform that this country is capital abundant must be, and the abundant factor capital will gain because the rental on capital will increase by 60%. And the scarce factor is labor. Labor wage rate will decrease. Labor will lose because this country, the relative price of computer increases, and computer is the capital intensive goods. And because the country export capital intensive goods, this country's abundant factor is capital. So this everything be connected. I know this is kind of a lot of hassles when we derive all these equations, but once we get everything connected, then you will find this is very, very interesting. So last piece of question, what about the real income? Because we talk about real earnings. This is not about real income. So this wage rate, say, decreased by 40% or rental increased by 6% is not real income. The real income is you have this nominal income change. Say you got $100 or 10% increase in your income. You have a pay raise of 10%. You're so happy. But your real income may not actually increase by 10%. Why? Because the inflation. If everything becomes more expensive, like 20% more expensive, because the inflation is coming, because maybe the government issued too much currency. So your wage rate increased by 10%. However, the inflation increased by 20%. Then you cannot afford as much as before the inflation. So your real income, it will decreases. The real income equals the nominal income change minus the inflation. So the inflation comes from the price change, percent change in price. So the computer has a 10% price increase and shoes has a 0% price increase. But if this is the case, if we use 60% to compare the highest percentage change in price in computer, we will say that the rental, nominal rental minus the computer price change, which shows the real rental change, real earnings to the capital, it still be 50% in terms of computer. So that means no matter of what, well, the capital will gains, be the real winner, because the real income increases in terms of either computers or shoes. In computers, the real income change will be 60 minus 10, 50%. In shoes, it will be even higher, 60% increase, because shoes price doesn't change, and the nominal income change equals real income change. For workers' wage rate, their wage rate already dropped by 40%, and then computer price increased by 10%. So if the workers use their money to buy computer, you will find in the real term, how many computers they can afford will decrease by even more. So that's 40% minus 10%. So it's going to be negative 50%. So the workers' real income may even drop even lower. In terms of shoes, workers' real income will be 40% minus 0. So will be negative 40%, will drop by 40%. As shoes price doesn't change, so the change in their workers' income equals their real, like a real wage change, well, to telling how much shoes they can afford, which is 40% less. So in either way, if we compare the nominal term with the price change in both schools, we will find the real income change on capital will be positive. So the abundant factor in this example will experience a real earning increase, real income increase. And the scarce factor, labor, in this case, will have a real income earning decrease, no matter in terms of which goods. So that's about the Stolper-Samuelson theory. And it seems like these examples 100% completely support the theory. Way to go. You did it. You survived this, the longest lecture ever in this class. And typically, we're going to use the full class session to deal with these questions, one single one, and you survive it. And I understand that, well, you may not remember the whole equations. You know what? You can write it down. You don't need to do the derivation to derive the equation every time, especially for the exam. You can just write it down and use it for future calculation. And you did it. I'm very proud of you. And there will be one question actually after this, and you can use the equation to check that, to check the Stolper-Samuelson theory. And it's almost the end of the this chapter, except for only one more thing, which is the Leontief paradox. It's a very short discussion on some empirical test on the Heck-Rolling model. And I will see you in that video. Take care.